Hi, this video is for Algebra 1 students, and today we're going to be talking about linear equations, and we're going to use the June 2018 Regents Exam to look at ways that they could ask questions about linear equations in the Regents Exam coming up. Alright, so a linear equation, the general formula for a linear equation is y equals mx plus b, or if we were talking about a function, we'd have f of x is equal to mx plus b. Either way, the important thing is that you understand what these variables mean. The m is going to be an actual number. It should be replaced by an actual number. And that's going to represent the slope or rate of change. And it's important to remember that linear equations have a constant rate of change. And that's what the m does, keep the rate of change constant for linear equations. B is the y-intercept, or the initial value of a linear equation. So that it's the y-intercept, like if we were looking at a graph, and it's the initial value if we were talking about a word problem or something. Y or f of x, either of these two, is the dependent variable or the result after everything else is taken on the other side. And then x is the independent variable, and that will just stay as x. Alright, let's go into a couple of problems in the June 2018 exam. Alright, which situation is not a linear function? 1. A gym charges a membership fee of $10 down and $10 per person per month. A cab company charges $202.50 initially and $3 per mile. A restaurant employee earns $12.50 per hour. A $12,000 car depreciates at 15% per year. Alright, so we're gonna take a couple notes on these in a sec. Okay, so in the first one, we can imagine the $10 down. That can be like our initial value for a linear equation. So that would replace the b. And then $10 per month, that's the $10 that's going to be multiplied by the x. And so that's y equals 10x plus 10. And that looks similar to our linear equation, which is y equals mx plus b. It follows the same format. There's y there, the m is 10, and then the x is there, and then the 10 is b. So this first one is a linear equation. The second one now. A cab company charges $2.50 initially and $3. So there's the word initially. So you're just going to know that's your initial value. So plus $2.50, and then $3 per mile. That's your rate of change. So that's the 3 that's going to be multiplied by the x. I'll just make that 3.0 multiplied by your x is equal to your y value. So we know that one's a linear equation, so we're not going to pick that one. And then number 3, a restaurant employee earns $12.50 per hour. Okay, here we don't have an initial value, but we can say our initial value is 0, so that's plus 0. And then we have $12.50 per hour, which is the rate. X is equal to y. Alright, and we don't actually need the 0 here because plus 0 just leaves it at 1250x, so it's pretty much irrelevant. But either way, we notice that it was a linear equation, and so that is not the right answer. Alright, so that leaves us with a fourth one, but let's just try to make an equation out of it anyway. So a $12,000 car depreciates 15% per year. Okay, so if we were to try to make a linear equation out of this, we would probably say like $12,000 is the initial value, but the 15 depreciates 15% per year. That's not a constant rate of change, because actually what we'd be doing is multiplying this by 1 minus 0.15 for this rate of change to happen, and that's not the same as our linear equation. So we're going to pick 4 as our final answer. Alright, so let's move on to another one. The amount Mike gets paid weekly can be represented by the expression 250A plus 290, where A is the number of cell phone accessories he sells that week. What is the constant term in this expression, and what does it represent? Alright, so here we have we can tell that's linear equation because it's 250A plus 290, or it's more of a linear expression, but because there's no y or f of x that it's equal to, but we know it's linear, and what we're looking for is the constant term. So let's look at our choices. 250A, the amount he is guaranteed to be paid each week. 250A, the amount he earns when he sells A accessories. 290, the amount he is guaranteed to be paid each week. Or 290, the amount he earns when he sells A accessories. Okay, so first off, we have 250A. We know that 250 is multiplied by the constantly changing A value, so that is not the constant term, so we could probably eliminate these first two choices. And then 290, that would be our constant term. You could also, which is our y-intercept, so you could also think of the y-intercept or this b value as a constant term too, in case it ever comes up in future exams. So now we need to choose if it's the amount he is guaranteed to be paid each week, or it's the amount he earns while he sells A accessories. See that how the A value doesn't really have an effect on the 290. It's always going to remain 290 because it's not being multiplied by that A. It's just going to be added to those two answers. So the 290 won't be affected by the variable A. So it's not going to be number 4, the amount he earns when he sells A accessories. So the answer is 3, the amount he is guaranteed to be paid each week, because even if he sells 0 phones in a week, he's still guaranteed $290. Alright, let's move on to another one. Caleb claims that the ordered pairs shown in the table below are from a nonlinear function. State if Caleb is correct. Explain your reasoning. Okay, so in this one, we're gonna try to determine if this is a linear function based off this table. So what we want to look for is if it has a constant rate of change, because linear functions and equations have constant rates of change. So let's look at the change from f of 0 to f of 1. It's changing by 2, because 4 minus 2 is 2. And then from 1 to 2 is changing by 4, because 8 minus 4 is 4, and then it's changing by 8 here. So we know that this isn't a linear function, because it doesn't have constant rate of change. There is a pattern to it, which it's doubling each time, but that doesn't mean that it's a constant rate of change. So what we would write here is no, or my bad, yes, Caleb is correct. Because there is no constant rate of change. All right, perfect. And now let's talk about graphing linear equations. When you're graphing any equation, really, even if it's not linear, make sure you're plotting points just so it looks more accurate, and make a straight line through the points for linear equations. And because linear equations should end up being a straight line. Alright, so this was question 32 on the June 2018 exam. On the set of axes below, graph the piecewise function f of x is equal to both of these, negative 1 over 2x over the domain x is less than 2, and then f of x is equal to x over the domain x is greater than or equal to 2. We know that these are still linear functions because there's the x being multiplied by, or there's x without any exponent on it. So, and that the plus b is really just a 0. So this is still a linear equation. Alright, let's try graphing this. Okay, so for negative 1 over 2 x, let's first try, or hold on. Oh, this one is for when it's less than 2. So that would be on this side. Let's create a line. That would be for only this side of the values of x. Now let's erase that. So let's start off with that one. Let's try to put 2 into this equation. So we have negative 1 over 2 multiplied by 2. And that's going to get us a negative 1. Yep. Yeah. And so we plot it at 2 comma negative 1 here. And then let's try plugging in for 0 now. So let's just erase this, or plugging in for 1 now. Then we put in 1 and it should be a negative 1 out of 2. But negative 1 out of 2. And so that's right here at x is equal to 1 and y is equal to, or f of x is equal to negative half. And then let's make one more at 0. Okay. My bad. Alright, so 0 just cancels out. And so it's 0, and then the point is at 0, 0. Hold on. This original plot should have been a open circle. My bad on that. Because it's it's not included within the domain. And then now we can notice that there's a pattern of it going up by half as we move towards the left. So we're just gonna follow that pattern. Honestly, that way it saves us some calculation. Here, here, here. I'm actually gonna just go by 2's now, because what really matters is the line that we draw at the end. Now let's try to use this ruler. I'm not. Never mind. Let's not use this ruler. I don't know how to use it properly. Let's just try to draw a straight line through here. when you have your exam, you're going to have a ruler, so just use that ruler so you're more accurate, but I don't have that right now, so I will just draw a line and go like this through my points. My bad. Let's erase that one. And there was a point right here. And then we go through. And then that's how we were able to make a linear equation for one of them. And then now we just have x for the other ones. And so let's evaluate for what x would be in 2. So if you replace x with 2, then you just get 2. And then, so that would be 2, comma 2 here. This one actually is close because it's within the domain because it's underlined greater than or equal to greater than sign. And then obviously x is 3 at 3, and then x is 4 at 4, and then we should be able to just notice the pattern of just doing this every single time diagonally. And then we're just going to go through and make a straight line, and we just graphed another linear equation. Alright, let's try one more problem with graphing linear equations. Alright, on set, my bad. On the set of axes below, graph the following system of inequalities. 2y plus 3x is greater than or equal to 14, and then 4x minus y is less than or equal to 2. Hold on. Okay, so first off, I want to start off by making this a proper linear equation, and getting y by itself, because that's what a proper inequality looks like. So let's go with the first, this top one first. So 2y plus 3x is less than or equal to 14. Now we want to just get y by itself, so we can comprehend it better. So subtract 3x from both sides, and that's 2y is less than or equal to negative 3x plus 14, and then let's divide 2 from each side. And now we have y is equal, nope, not equal, less than or equal to negative 3 out of 2x plus 7. Alright, and that's going to be on the next slide, so we don't have to worry about that not saving. And then for this one, let's start off with adding y to each side. And now we have 4x is less than 2 plus y, and then subtract 2 from each side. Now we have 4x minus 2 is less than y, and let's just flip these just so y is on the left side, just like this one. Y is greater than 4x minus 2. Alright, so now that we have these look more like linear equations, and linear inequalities are applied the same way as linear equations. You just shade in the below or above the inequality to make it complete. Alright, let's look at the next slide. And I put in what we saw before right here, except it's to the right rather than the left, but that's okay. And okay, let's start off with plotting the top one. So, oh, my bad. Something we could do with linear equations with y-intercepts, we can know that the at x equals 0, that it's automatically going to be 7 because that's what a y-intercept is. So 1, 2, 6, 7. Okay, so it's 7 here, and then it we'll try to do let's evaluate this for 2 first, just because I could solve it in my head and it would end up being easier than going with 1 first. So negative 3 out of 2 multiplied by 2 plus 7 is less than or equal to y. And then negative 3 out of 2 multiplied by 2 is negative 3 plus 7 is greater than or equal to y. And 4 is greater than or equal to y. And so now we can just plot that here. When x is 2, then y is 4. When x is 2, y is 4. And already we can notice a pattern that when you're moving to the right, it goes 2 to the right and 3 down. So I'm just going to follow that pattern because you can do that for linear equations. So that's 2 to the right, 1, 2, 3 down. And then 2 to the right, 1, 2, my bad, 1, 2 to the right, 1, 2, 3. And then it's going to be the opposite for going to the left. 3 up, and then 2 to the left. Alright. And now we just draw our line through it. That's going to be a solid line because it's it can also be equal to each other. And then because y can be less than it, we're going to shade down for this one. Alright, and then, or actually, let's do our shading after we make the other point. Let's use a different color. Go with the blue. Okay, so 4x minus 2. Our y-intercept is negative 2, so we can just go there right away. And then for x is equal to 1, we can evaluate that. 4 by 1 minus 2 is less than y. So we have 4 minus 2 is less than y, and then 2 is less than y. So when x is 1, y is 2. And we can already notice the pattern that same way we noticed the other one. When you're moving to the right, you go 1 to the right, 1, 2, 3, 4 up. So let's keep doing that. 1 to the right, 1, 2, 3, 4 up. 1 to the right, 1, 2, 3, 4 up. And then the opposite for the other one. 1 to the left, 1, 2, 3, 4 down. And left, 1, 2, 3, 4. And now we can make our line through it, except this time we're going to make it a dotted line because the equation cannot be equal to y, or the line cannot be equal to y. And I wish I had a ruler to make that straighter, but I do not. Okay, and now let's do our shading. Alright, so let's shade for this blue one first. Because y is greater than the equation, we're going to shade up. And we're just going to shade all values of y that is above the line. And then for this one, this equation is less than or equal to y, so we're going to shade below the line. And the solution set is where the two intersect, which is this both blue and orange area. And this doesn't have to do with graphing linear equations, but this was also part of the question. Determine if the point 1, 2 is in the solution set. Explain your answer. 1, 2, let's just take away the shading because we don't need it anymore, would be right here, or 1, 1, 2. This would not be part of the solution set because remember this is a dotted line, and so 1, 2 isn't part of the solution for this one, and the solution set includes both the solution for this one, for the first equation, and the solution for the second equation. So no, it isn't in the solution set because it does not satisfy the inequality, or the second inequality. Alright, I hope you guys got something out of that, and that's the end of the video.